Hello, my dear students, and it will be a practical class number 3 now, but this time no task for you. This time only information, explanation, video, and I don't wait you to read much about phenomena we're going to discuss, but at least I need you to be familiar and to take this information into account. No practical task, meaning that I demand you something to do in response to this, in contrary to previous couple of practical classes. But this time, information no less important for you, I hope, will be than information of any another our lecture or practical classes. What I would like to start with. You see in the screen right now, beginning of the video that I have already once sent you a week ago, no less. It's called Kalinin K7, K7 maybe in English. I just call it as I get used in our language. Kalinin is the name of designer, and K7 it's the number of the name of the airplane, the number of airplanes by order. It was already the 7th successful project. Konstantin Kalinin has been developed in our country. Well, this video I stopped and show you immediately on the place where you might have seen it, and remember it's called Russian Flying Fortress. It's airplane of 32nd or 33rd year, and airplane of revolutionary type for that period, and it was huge, and it was flying wing, and so on and so forth, and it was crashed in the one of the testing flights. And after this project was stopped. Reason why it was crashed, I would describe it then, but it was not explained. Why I start with this, with these photos and with this explanation? Well, anyway, it's historical information. It's interesting, and it's immediately related to Kharkov, and to our university, Kharkov Aviation Institute at that period. As I said, you know that maybe already you do remember that Kharkov Aviation Institute was founded. It was like separated from another institution, Kharkov Polytechnical Institute, and it was found especially for preparing the engineers, the staff for the Kharkov Aviation Plant. And Kharkov Aviation Plant, it was practically the plant for Kalinin Design Bureau. Before this, he'd been working in Kiev with another, under guidance maybe of another designers, with another designer group. And Kharkov in 30 years of 20th century, it was a capital of Ukraine Socialist Republic. And even by now, Kharkov is called the first capital. No, just like equal names, Kharkov and first capital, historical capital of Ukraine. And that is why he moved to Kharkov. He was moved to Kharkov with his design group, and it was here the special plant for them. And this plant not far from Kyiv. No, on foot, it's around 20 minutes even for me, and I'm already 53, so I'm not so big runner, I would say. 20-25 minutes, and even on foot. When it comes about automobile, it's literally 2 minutes from Kyiv. But we are going to talk not quite about history. We are going to talk about aeroelasticity. Let me to show you where you might read. In case you're interested, you may find in the books that I'm already sent you some places with explanations, and one more file I will send additionally after. Don't think that you really need to read much about this, because it comes about more complex matter for understanding, but at least you should be acquainted with. Look, aeroelasticity, Flutter, shimmy, buffeting, and one more place where we may read about here is, you see, the whole, no, seems like chapter, not explain it literally here, not explain it. In the Stanford book, if I'm not mistaken, let me to show you. Yes, that one. No, Cambridge book. Cambridge Aerospace book, aircraft design. And in other books, you also might find it if you need. No, not really sure. You need read about it much. Let me do something like this. Practically, it's not explained in this book, for instance, but in most of books, this word is mentioned, and it's mentioned time to time without explanation, like commonplace, everyone understand. And in order we, and as I said, we have one more file, aerodynamical Flutter, but the in this explanation in this article, I trust it's more scientific, like it's too much for you. I may send it to you in order you have something to read, some things to read if you need to recollect it. But certainly it's not necessary to study seriously these texts. Even textbook will be more than enough, textbook of Fedotov, to read some words maybe which we misunderstood just by listening or something like this. Well, talking already too long about nothing, let's see what I said. First, I'd like you to see some things. No, and like it's usually said in such situation, take out children and weak health people from screens. Sorry. It's long movie. First, let's see short. Oh, it disappeared again. Short one, it's called Aircraft Flutter. Names are similar. I took it, it's free streaming platform. No, literally grabbed it, copied it. I know sound is hearable for you. Sorry, stopped it to find where sound control it. Here is, because sound will be too noisy together with my voice. Okay, it's a flight test. Know about flight test. We talked literally some sentences about testing of airplane. It's so-called certification flight tests or flight test of new concepts. It's necessary to check whatever we may even calculate, even by means of modern computers and computational mechanics. It's necessary to check it in air, in real structures, on the ground, in air. Structural analysis must be checked because it's too serious. And when it comes about failure of fridge, for instance, it's unpleasant, but it's not catastrophic. No, in most of cases, of course, if no one poisoned by food from this spoiled fridge. But when it comes about airplane, failure in air, especially, you understand, it's catastrophic because it's maybe resulted with death of people. Point your attention next to the rear edge of stabilizer, to the elevators. Let's watch. You see some vibrations have started, and it's already now it's already very similar to butterfly at all. But it's flutter. It's named Flutter because it's really fluttering like butterfly. And one more movie will show you also short, also impressive, more impressive than this one. That was simple, pleasant. Partially we will see it in the next movie, and propose you really be ready to unpleasant impressions. Sorry. Also made mostly of American short clips, short videos. This thing we have already seen. Next one. In this case, it's not stabilizer, it's a wing. Flattering, and you see all over the wing. And it looks like not just oscillation, it's like combined with both bending and torque. Now it's another airplane. Look what happened. At some speed, it's appeared trembling of ends. Quite clear, it's already flattering really, all the wing is flattering, look. And it stopped. Uh, let's take attention once again to that place. How to control you. Oh, seems like it's disappeared the line of controlling. Okay, next we will find how to repeat it. That place. And that you have seen the real structure, and now you see a wind tunnel. No, time to time it will be a real structure or wind tunnel. Now fins trembling, it's called buffing. It's not flutter by name. No, reason is the same. Next we will talk about reasons of these things. As to my understand, it's already not a test. Someone made it immediately in flight, some passenger. That airplane that we have seen in pictures, in photos, now we understand what this funny creature is necessary for. It's really for testing, for, no, it's like conceptual airplane for checking of some theories, of some sleepy moments, let's say, in aerodynamics of airplane. And we have seen flutter of its canard stabilizer. Now flutter of the rear stabilizer. And do pay attention, it may appear and it may be stopped at some moment. First, we need to understand reasons, also stabilizer. We need to understand reasons. Why, what, for instance, why stabilizer is trembling, but wing is not trembling? What is the problem? Yes, look at this portion of screen. Look what happened, and okay, sorry. I, as I said, you time to time it's maybe extremely unpleasant, this video. Moreover, until we are watching, I should find something to calm me down, because I've seen these movies already dozens, maybe even hundred of times together with my students and individually, but I still don't like them. And what we see right now already, no, no idea why it doesn't show me this line and ability to control. Now we see a wind tunnel test, and this wind tunnel test now been demonstrating, studying already the ways how to prevent flutter, how to counteract flutter. No, at least attempts how to counteract flutter. Now, do imagine it may happen in real flight. It may happen in real flight, especially at transonic speeds. Phew, dreadful movies actually. Thanks Lord, they are not endless. No, I'm afraid we have seen already enough, and next you will continue to watch it if you'd like. Already without me, and if necessary to repeat, we will repeat it. Moreover, I have found old Soviet movie which is been recommended like tutorial in no, almost 40 and something years. Да, 14 and something years ago, it was issued and recommended as tutorial for students in aviation universities, institutions. And let's come back to our slides. Being opened. Oh, we are now, you see, a reaction of normal person to, oh, what it was. Flutter. It was Flutter. What is Flutter? Flutter, it's so-called self-oscillations. Wait a second. We need. It's the sort of self-oscillations that appear in system. Sorry, no idea what happened. Oh no, Word. Okay, I will open it again, but seems like it's hanged. Ah, no, it doesn't hang. It's okay. I thought it's stopped the work. And no, colorful picture at the bottom. You see? In case you have not seen the movie, you say, ah, can't be. Never in life it's maybe like this. But in real life, it also may happen like this. Word, to stop your tricks, please. Sorry. Maybe it's opening too much files. In this case, internet can't be responsible for. Oh, may you give me back my illustrations, please? Let's close at least a couple of files. Maybe it will help. Too much files are opened, maybe. In those places, in another places. Sorry for such behavior of computer. It's a list of yours, of your group. Practical is the same picture, as you might see, that I'm going to use now. And how Flutter is appearing, and how it's appearing, disappearing, the picture in the screen. Okay, let's use this one yet. How Flutter is appearing. It's once again it's a sort of self oscillations. These self oscillations usually they appear like bending and torque motions. Altogether, the travel of the wing, you see, it's the wing, cantilever wing, the wing on the way. Let's say we see airfoil from the right to the left, how it's moved, and airfoil has center of pressure and center of gravity. And center of pressure, center of gravity, they usually do not coincide. Moreover, I hope you do remember that the center of gravity for the airfoil, in case it's not fuel tank, it's practically the same. It depends on the structure, how structure made, how structure really arranged, what it consists of, how many spars, where the spars are, what is the thickness of skin of another elements. So center of gravity, it depends on structure itself. Center of gravity in one cross section, let's say right now. And the force which is resulting aerodynamical force applied in the center of pressure, it's resulting force of all the aerodynamical forces acting to the surface, to the skin in real case. And it's applied in some another point. And moreover, as only you change angle of attack, the point of center of pressure and resulting force itself, it may float a bit, a little bit. There is another point which is called focus, and this focus is stable with respect to the nose of the airfoil, let's say. It's in the same position always. But center of pressure, it's floating point. And what happened? Look, Flutter may happen. It's like self-oscillating and it's self-supporting, let's say. It's not caused by permanent intrudence of some additional energy. Once started, it's continuous until conditions for this Flutter do not disappear. And it's necessary to understand what are these conditions, let's say. So at some speed, it's usually called critical speed of Flutter, and those speeds, they are rather high, and they are in a transonic region as a rule. So at the speed of 0.8, 0.9 of Mach number. At some speed, especially in case of additional sharp addition of wind, for instance, so-called relative wind, the air downwashing the airfoil on some speed is constant, let's say, and some disturbance, no, like let it be the wind occasionally, or some, for instance, some increases in thrust, some sharp increasing in thrust. Someone in the cockpit moved the handle for engine. What may happen in this case? In this case, as only you increase the lift, forgot to prepare this formula, Zhukovsky formula, you already like perforated with this formula, have to be by this moment. Y equal to coefficient of lift, kinetic energy of stream, rho v squared by 2, and area of the wing. What happened if you increase velocity v, increasing in lift? So sharp and like unpredictable increasing in speed, not always, but in this transonic region, approximately transonic range of velocities. What it resulted in? Sharp increasing of speed of relative wind, so-called, and it's appeared additional lift. What this additional lift do? It's increasing the lift, but it's no, pilot doesn't meant to increase angle of attack of the airplane. Yes, angle of attack is the same, but wing is not stiff enough. Wing fixed here, it's like clumped here at the fuselage, inside the fuselage or in the center wing. But the end of wing start rotates. It start change position to this new position. No, this position number second, you see. Additional lift has appeared, and this additional lift responsible to increase angle of attack. And it's continued to increase angle of attack because, the greater angle of attack, greater CY, coefficient of lift, and as a result, it's increased. It's like trying to rotate the wing, but it's not able to rotate whole the wing because wing here is fixed. And it's twist the wing in such situation. But we do remember that material, in order to keep inner balance, according to the third law of Newton, material have already prepared the response to this, and material start counter rotate, so-called elastic forces, inner elastic forces. They counteract to this attempt of the relative wind to rotate the wing, and it start retwisting again, and they are trying to place wing to the previous position, and cross section rotates down again, but it rotates too much because of these balances of forces, and now it's in negative angle of attack. But here we still have velocity relative wind, and this relative wind trying to rotate wing again. So it's like a superposition, combination, superimposing of two motions. On one hand, relative wing is trying to rotate it, to torque it, to twist it along with respect to the center of gravity, and a wing is coming back, and it's create such motion up down. Plus to this, wing yet in travel because it goes through the air, and plus to this, I've been talking about the only cross section, but actually it's somewhere along the wing, some of these cross sections, and somewhere it's relative force, the whole half of wing is placed, and besides of this torque, besides of this rotational motion along the span axis, it's also bent, like waving in this direction. And result you see, it's not just rotational motion and linear motion, it's like a wave itself. The tip of the wing, the root of the wing is stable, it's fixed in the fuselage. The tip of the wing is move along some wave-like travel and rotates permanently in this direction. Now, what is the problem in this case? Problem that some surfaces became unusable, uncontrollable. It's not the question of just dreadful vibrations in the airplane or in some places of the airplane. Control surfaces are not about to work in this situation because downwashing is abnormal, and the effectiveness of control surfaces, it depends on the, you do remember, depends on the area of control surface that have to create additional forces that we are going to use for control. But we still have the same arm to control surface, but control surface is not able to give proper force. Why it's not able to give proper force? Because mode of downwashing is abnormal, no, so on. So control surfaces, they are working, but not sufficiently. Like they are, no, the lack of control in this case over the airplane. And the worst situation, as I already said, this self-oscillation, so-called, they continuous, and they no one, no, it was enough some first additional portion of velocity of aircraft that this self-oscillation started, and after this they continuous without stops. Moreover, they may be even increased in their amplitude, and they became worse and worse. No, quite we have seen in a movie, like say self-developing oscillations. That is the worst case of Flutter, of course. And moreover, no, you know that each structure, even each blood vessel in our body, they have so-called self self frequency, its own frequency of inner oscillations. But there is such phenomena resonance. If you know, if two oscillating systems will like they coincide with their frequencies, what it resulted in the outer system that makes these oscillations, for instance, and system that you're dealing with, if frequency of oscillation ideally coincide, what may happen, it's appearing sharp increasing of amplitude of these oscillations, like this energy joined and multiplied. In terms of technical structure, it may be resulted in destroying of structure, sharp and quick destroying of structure, like we have seen it immediately in the movie about Flutter. No, you have been witnessed it, like it's broken the wing immediately in flight. And no, this situation, of course, it shouldn't be should happy to the airplane, and that is why this phenomena been studied. They have started. No, scientists have started this studying of this phenomena. Maybe it's really happened since the moment of K7 catastrophic flight. Here is the another movie, and I trust this movie was made by some citizen of Kharkov. He made short in terms that like 10 minutes. I do not propose you to watch it. I just will show you some places of this movie in order you might see real no real movies, real evidence of case K7 flight, and that flight that was unsuccessful, and it was maybe the very first case when people at least have an idea about possibility of such situations. No, there are some first models of Kalinin airplanes shown, and it's yet about his previous structures, which been in wide use by the world in Soviet Union. And finally, guys, K7. Oh, here is, it's real movie. It's not photo. It's not something, well, that is a photo, of course, but previously it was real movie of K7 flight. And that is the model of K7 in our aviation plant, in museum of our aviation plant. And there are some photos that you have seen in other short movie. Let's leave it. And photo of flight, and now the chronicles documentary about this K7 at the airfield. It had some test flights. It was unique airplane for that period. And next will be the photo of last flight. And by evidence of those who survived in this catastrophic situation, problem have started on while sharp increasing of speed. When speed was increased sharply, they have some test flight with recording of parameters and so on. And on low altitude, comparatively low altitude, now it's his last flight, and it's, you see. Problem have started from sharp increasing of the speed. After sharp increasing of the speed, it start trembling, buffing of the stabilizer. This buffing of the stabilizer has been resulted in destroying of some structural elements, control surfaces as practically does not exist at this moment. Airplane became uncontrollable and it was stalled, as we have seen in this movie. Not quite clear, it was explosion and so on. After this, with appearing of the airplane of high speed, of course, K7, it was really unique. It was huge, unique airplane for that period, and it was like coincidence, bad luck, let's say, in this case, that it was subjected to this phenomena, flutter. But as no one understood the reason, actually, and it was expensive program, no one wished to risk, it was stopped. But time to time, next such unpleasant situations been happen to the less in size airplanes, but speedy enough. And of course, the airplanes changed in design, and they grow in speed. And with appearing higher speeds, this situation may happen more and more. And people start studying this phenomena. And approximately after Second World War, in 15 years, already was known very well that reason of this self-oscillating, it was mathematically already described, proven, the whole theory, not only hypothesis about what happened in that or another situation. And people understood that this self-oscillation, they may appear on some speed. Occasionally, they may appear in some range of speed due to sharp increasing in speed. And due to occasional factors like additional energy of wind, for instance, or additional energy of relative wind because someone increases the thrust. They happen at some speed, but it's not fixed value of speed for all the aircraft at all. This value, this critical value of flutter, it depends for different structures of airplanes. It depends on the airplane general structure, and it depends on aircraft stiffness. The new word for you, no, not completely new. We have already talked about how we select cross sections of substructural elements. And on one hand, we are striving to concentrate all the mass, let's say, to the places with maximum loads in order to save weight, in order the most loaded places work more than unloaded places. On unloaded elements in structure, they are removed, they are thinned, they are removed at all in case they do not take in receiving of loads and counteracting to the loads, resistant loads. They are not necessary in aircraft structure because we do remember we are obsessed with the minimum of the weight. Minimum of mass of airplane is the first ever rule that we should follow too. And for different airplanes, of course, minimum of mass, stiffness will be different. Some airplanes, like those which we have seen today in our slides, in the same program, what in those photo, it's greatly visible. Which one will be subjected to the flutter? This one or that one? Not certainly this one, because it has convenient for Flutter parameters, let's say, of configuration. It's less stiff wing in this case. It's best glider. It has better aerodynamical drag. No, I mean less aerodynamical drag and higher aerodynamical quality. But in this case, structure isn't stiff. How to increase the stiffness? Do inner elements more heavy. Do them more massive. Do them more thick. In case they are more thick, they are more stiff. But in case they are more thick, in case they are more massive, they are more heavy. Circle is closed. In case they are heavier, we need more area of the wing, we need more fuel, and so on. So seems like it's not ideal decision, a bad decision in this case to increase the whole stiffness of the wing. It's a bad decision. Because it's resulted in overweight, in overall increasing of the weight and subsequent increasing of the necessary fuel and subsequent need in additional thrust, changing the engine. Dreadful situation. So it's not good situation. And it means that it's necessary to find some another means for counteracting to the flutter. But do remember that it's somehow related to the general stiffness, to the stiffness of each cross section and to the stiffness of the wing or whatsoever at all. I didn't say in the book, not book, file, maybe it should not be called book. Where is it? Here is this one, aerodynamical flutter. What you see here, the same bending torque motion of the tip of the wing, of one of profile of the wing. And here is explanation about what flutter, how it's understood what flutter is, what the sort of phenomena flutter is. But take a look that it said that flutter may encounter it in flexible structures, in non-stiff structures, subjected to aerodynamical forces like building, telegraph wires, stop signs, bridges, and so on. Yesterday, I've been seeing some movies and decided not even to show you such situations in order not to scare you. Flutter of bridges in some real documentary movies about flutter of bridges, and even in one case it's shown like bridge been broken. Self-oscillation that appeared due to the wind, for instance, self-oscillation appeared due to the wind, and this self-oscillation is continuous and increasing in amplitude just because it's coincide with no inner frequency of inner oscillations of the structure, like such unlucky case. And how to work against the flutter, let's say, to increase stiffness. But as I already said, the whole stiffness increasing, it's not a good way to solve this problem. Wait a second. it's not Fedotov who may show us. I'm afraid how to solve it. Da, it's not here, so I'll try to explain it on my own. I have prepared the picture. Thank you. What is it? It's traitor. This program. Sorry, let's open it again. Traitor. We need slides. We need. It's not even that. It's not even show us what we really need in this list of files he lost. And again, it starts these tricks. It does not show the pictures. Why? Okay. Well, at least it show it here. I hope all the pictures at the place. Not for sure. Show me. Almost. Yes. Так, I need another one. Sorry. Happens. That one. It doesn't save me some pictures. I see. Какого? And let's use it here. Here is, we already talked about, at least mentioned about. Here is a load diagram, or it's called a pure of loads acting to the airplane in flight. In order you understand what it's shown here. What airplane, let's copy once again. What loads airplane may be subjected to. Look, there is a load of its own weight, and no, it's like gravitational forces acting. And on the ground, airplane loading looks like. It has only forces acting down. And these forces acting down, they distributed, like along the span of the wing, they are distributed, or conditionally they are concentrated. What does it mean, conditionally concentrated? Look, engines on the wing, for instance. And it's not good, yes? It seems like they overload the wing. On the ground, yes. But what happened in case you loading the wing in air? No, also we have some distributed load. It's maybe even shown like distributed with the same value. In case we have straight wing, in case wing is with of tapered shape with different root and end at the tip, distribution here is less and here is higher in value. It's not bending moment. It comes now only about the shear forces, so-called. No, it's not shear forces, it's load. So shear forces, it's respond to the loads. That is external loads to the airplane. Gravity loads and air loads. And in places, what besides of the loads that distributed even equally might be, as I drawn here with red line, this red line, its maximum thickness, sorry, it's distributed equally. Let's imagine that we have, it's called bending moment. What does it mean, bending moment? It's cantilever wing. Wing is fixed here with the fuselage, and free tip free piece of wing may bend under the loads. It's bent. uh, Pay attention that here is, for instance, some force and an arm, sorry, and an arm uh, of to this force. Here is even the same force, but another arm to the plate. Guys, to forgive me, I need to answer. Phone calls always disaster. Do forgive me. Switch off sound. Great. Sorry. And bending moment. So bending moment grows, and its grows closer to little forces. What here is the little force. It's practically no bending moment here. But when it will be somewhere here at this place, it will be already a significant load. And load due no load in the view of bending moment, it's approximately like this distributed. It sharply rise to the place where you have cantilever wing fixing somewhere. And what about engines, which now own the wing, and they are seems like they are guilty for overloading the wing. Look, aerial loads, they bend the wing in this direction. And what do the engine, which is on some distance from the fuselage? It's also bend the wing, but in counter direction. Let's use another color for it. Green one, because it's a good one, let's say, ecological one. It's counteract to bending moment of aerial forces. Of course, it's summarized additionally somehow with bending moment due to the weight of structure itself. No, whatsoever superposition of these two lower diagrams, which is final diagram, it will be like here is we have some growing of bending moment, and since this moment where engine is, it start growing not so sharply. It's like reducing the peak of bending moments of inner responses in stresses, inner stresses inside the structure. So inner loading of structure will be not so dreadful, not so significant. In case here on the wing you have engines. So however weird it sound, but in this case wing may be less in weight. And additionally, such positions of engines, it's somehow like it's in stiffening the place this wing, because around of engines you need to reinforce the structure of the wing. And I may prove my word, no, an attempt at least to prove my words with the photo of R380. As for me, it's greatly notable, greatly visible. What here is on the ground, of course, it's already, no, I have found photo in order to see it front. Can't find like more no, understandable photos where it's visible even better. The shape of wing, like brace-like. Now it's already a little bit loaded with wing loads, I trust. But it's yet brace-like, you see. Uh, like it's hanging a bit to sides. In a photo where A380 just on the ground without runway, it's very well visible. No, just haven't found such photos. And now to pay attention what this wing looks in flight. It's not straight. It's even a little bit tipped. No, tips are moved up. Like it's straightened. It's practically flat in flight, and tips little bit higher even, no, as it seems. I'm not talking about the winglets. I'm talking about the general shape of the wing. So here it's visible that wing on the ground and wing on the in flight, they have literally different configurations. On heavy airplanes, it's very very visible, let's say. And you do remember that this one is one of the heaviest. I can't show it in our airplanes because they use not low wing. They usually high wings, and they have another angle of this lateral stability. They are not dihedral but anhedral. I mean, wings like directed to another side, besides of its high wing. And in this case, it's already hanging to the bottom anyway. Well, so people understood the matter with this Flutter possible way to prevent it, and people start counteract to Flutter, changing the stiffness of structure, adding additional weights, additional not loads but additional masses into structures in order what to have what in order sorry, at least we might use the picture in this book, how originally what is guilty, let's say, in structure of the wing or some another airfoil surface, that it start this rotation. Center of pressure does not coincide with the center of gravity. And for preventing the flutter, it's important, seems like, to no, to combine these points, to merge these points wherever it's possible. Of course, it's not possible for always, but at least it's possible to change the situation. It's possible to merge them in some cross section, in some flight modes, and additionally, it's necessary somehow to counteract to the bending of the wing. And why I explained it to this story with no, with these load diagrams and with this engine loading the up, no, in contrary, unloading the wing by engines in flight. Human thought went the same way actually. If structure try to wave by tips of the wing, let's make structure where is disappeared. Maybe I closed it. Let's make structure heavier. No, yes, well, no, goes not with the best way in this meaning. But let's make structure heavier. I hope this one. Show me. Yes. Why you don't give me to control movie? No idea what happened. No, you see, a computer behave unstandard way today, time to time. We will see it at some moment, and I will stop it. Uncontrollable movie, how it can be? Of course, I may try to use TikTok viewer, but in this case, maybe it's not in TikTok yet these videos. It's maybe even longer until it's downloaded. It's working well, but it's internet, and it will be necessary to wait until it's downloaded and so on. No, very well. Anyway, we yet watching these dreadful things somewhere here approximately. It's in a movie. Oh, and until we are waiting, I'll prepare one more. Went away, please. No, not like this. Oh, Flutter yet. It will be a wind tunnel test, and it will be visible what people studied, how people studied, how to stiffen the structure. Somehow it's similar to what I tell you once about the changing of cross section, that we dispersing, let's say, the weight, changing moment of inertia of structure. Instead of using just rectangular structure, we might use L-shaped or T-shaped structure for stringers and for stiffeners, because they have the same strength, but they will have different stiffness. No, example with folding the piece of paper and like place piece of paper to the table vertically and place the hand over, and it's folded, it's buckling. And if you, where am I? But better not to see this. And when you fold it sometimes, the same piece of paper or the same cross-section, or general cross-section, general area that counteracting to the compression in this case will be the same. But as you fold it, it's already not buckling, or it is buckling not so significantly. Fold it, place it vertically to the table, and place the hand. And more probably it's able counteract already to the to the weight of your hand. Now, what do we see? It's so-called weight balancer, weight balance, additional device, additional weight, unnecessary in terms of neither aerodynamic, neither of purpose, no of purpose of aircraft. But look, people study how additional weightening on the wing, additional mass added to the wing may counteract to flutter. And let's watch once again. You see some even missiles, да? And you have seen at the tip of the wing, it was shown, it was something like a tube protruding to the front. Such devices, additional weights, no, besides of we may use for anti-flutter purposes some elements like uh, engines, nacelles for landing gear legs, as we have seen it in previous class photos. Cruise missile that in fighter, for instance. In some cases, and it's important, especially for control surfaces, control surface might have additional weight in the nose on purpose to change stiffness of it and to control the center of gravity of it, to change center of gravity due to adding extra weight to the nose. And one more way is to change the stiffness and center of gravity of the whole such control surface by adding additional side structures to it. And these balancing structures, they change the ability to bend and ability to torque of all the structure altogether. Of course, they are overweight, but in case this airplane has problem, may encounter the problem of flutter in flight, it's more safe, it's more rational to overweight the structure and deal with extra expense in each flight than to risk with human life, pilot life, human life, not even with the airplane. Airplane is just money and time for its constructing. Yes, it comes about billions of dollars, but it's just piece of metal, no, very expensive, but piece of metal, in contrary to human lives. And let's see the movie. No, one more movie, as I said you, that one sound is switched off completely. No, It's movie about the loads. It's, as I said, you tutorial movie about the loads acting to the airplane in flight. Вот так, да. It's also not. Oh, great. It's also not movable. Slider. I can't control it. No, do forgive me. In this case, it's not something I may use right now because it's rather long, and as it long, I not agree to wait for 10 or 12 minutes. I will try to find it right now at the place where I took it. No, here is tutorial movie. And it's even better because it's helped me to scroll it properly. Look, we see loading of the wing, not normal loading of the wing in flight. You understand already these diagrams. Uh, it comes about the distribution of pressure over the airfoil, and it shows the center of pressure line, and center of pressure line, of course, for each cross section calculated, and it's where is it? Center of pressure line calculated for the each particular cross section. As I said, it's resulted in some lift force, and this lift force aerodynamical loads. What here is, we see distribution of these aerodynamical loads. Altogether, they may be represented like something acting like equal force in the center of pressure of the airplane as a whole. All the forces acting to the stabilizer, to the wing, wherever, with respect to the gravity center, and additional forces which appear due to engines. No, in this case, thrust, you see. It comes about external loads, the weight of structure, the weight, aerial forces, aerodynamical forces, and so-called concentrated forces. Concentrated forces, they are usually forces of engines, of landing gear weight, no, and some distribution loads inside the fuselage, passenger and cargo weight. Так. Result. What here is, we see this distribution of forces. So pay attention. Resulting load of resulting diagram of loads. It has like less places here. No, instead of increasing in this place, it has reducing in some places. Where this reducing is in the place where we have engines and in the place where we have fuselage, because it's also like reloading the wing altogether. No, in this place, retracting the landing gear, and what next you are going to show us again about loadings. About no, now it's about loading and non-coincidence of loading with the center of pressure and appearing of torque moment, how torque moment is appeared in the wing, because center of pressure does not coincide with uh, center of pressure doesn't coincide with the center of gravity in each cross section. Here is comes about so-called inertial forces, I trust, which appear due to no, it's not about inertial forces. It's about different calculating cases for aircraft strengths according to norms of ICAO. I've been explaining you that different maneuvers of airplane, including cruise flight, takeoff, landing, rolling, pitching up, pitching down, even for civil normal airplanes, we have some calculating cases, and here they are all explained, like what sorts of loads and overloads act in that or another case of flight according to the airworthiness rules, regulations. You see, animation of 40 years ago, non-colorful and rather specific. Oh, sorry. No, it was explanation as to the different forces acting in different situations, and how these forces may be studied in aerodynamical laboratory. Here is wind tunnel test, and this wind tunnel tests may be done in for horizontal flight. For it was imitation of stall, as you understood, when airplane rotates and move down together. Now it comes about bending moments, and it comes about the shear forces, torque of structure at all, inner response of structure that appear as no, as response for the outer loading in different places of airplane. And we need to see the place that I've been talking about. That extra loading, which may be resulted in even fatigue, no, fuse fatigue problem. Fatigue, it means after cycling loading, structure may immediately, even at low stresses, at low loads, structure may crack immediately in front of you, or it may grows the cracks, and next these cracks increase it in size, grows dramatically, and result is the whole breaking of the structure. What now we see the flutter, studying of the flutter in, I went back a bit, studying of the flutter in big wind tunnel on the scaled model, you see, and no, whatever this airplane is, you might see right now the trembling of elevons must be in this case, because it comes about delta wing, and there are a combination of elevator and uh, ailerons, elevons, so called, that we have seen flutter. Nothing new for you after you have seen that dreadful NASA videos, of course. And here is explanation how flutter, what it looks like, how it's appeared, how it's continued, and what it may be finished with. And one more thing will be shown that I have not seen in some another place or another video. There is so-called, it's not aeroelasticity. Of course, it's somehow also related to our aeroelasticity, but it's about the non-stiffness of structure. Similar story may happen to landing gear nodes, to landing gear legs during runway at takeoff and landing. Look, it's called shimmy. You will see it in practically in real. What here is, you see, it's like, oh, there is what happened. It's start dancing, no, like along the way. Let's say uh, it's rather similar to the flutter, but happen to the wheels. When wheel rotates simultaneously with motion and bending, and and this we will stop. This we will stop in order to see the skin of shimmy. It's not here. It's in slides, which disappeared again. Great. Got tired of your tricks. Do forgive me. Seems like all the photos has disappeared in this file. That is file with your user tasks. No, slides. Ah, it's not tasks, it's slides, really. Oh, here is scheme of problems that may encounter the landing gear. You see, it's no, on one way, it's start rotates, and due to this it goes aside to the left, to the right on the way. Because of this way to the right, to the left, it's also bent the no, it's visible, да? It's bent the leg itself, and finally all this may be also finished with destroying of the landing gear nose. Oh, landing gear leg. Sorry, why I call it nose today. And that is the same practical is the same problem. It's a problem of aeroelasticity of landing gear that happened due to non-stiff structure in some moments. Once again, it's not finished up for you with some task to do. I hope you will read a bit in a book, no, literally a bit, because it's not for first years to understand it completely. I'm not waiting you to understand some complex mathematics or aerodynamics in this case. I just need you to see and to know this phenomena. No, you have seen it in real, in movies, and you understand it's not some theoretical construction, let's say, some theory. It's practice, and moreover, the studying of these phenomena, they have started immediately since the moment when we met this dreadful situation in life. No, and it's appeared that maybe first time ever it happened exactly in our city to our designer Kalinin to his airplane K7. Let's stop on this. To see you next time. Goodbye.